So for today's lesson, what we're going to do is talk about the beginning part of circles, and we're talking about arcs and angles today. So this definition is something that you should know already about circles. So the circle is the set of all points that are equidistant from a fixed point called the center. A segment that goes from the center to any point on the circle happens to be called your radius. And all radii of the same circle have to be congruent. So there's something that's called a chord, and a chord is a line segment that joins any 2 points on the circle. If this is a chord that passes through the center, that happens to be called your diameter. The diameter happens to be the longest chord of any circle. I think that probably would make sense. So take a look at the picture and take a look at what they're asking you to do. They're asking you to find the following. I'm only looking for one answer. There might be multiple for some of these, but they want the diameter. The diameter is a chord that passes through the center, which means it's the line segment. You have to label it as such, line segment AC. A radius, that's any point that goes from the center to a point on the circle. It's also a line segment. I'm going to go for radius OB, not the only one, just name one. And if you name a chord, not the diameter, but a different chord, you'd have any 2 points on the circle. So I'm going to name one of them DE. Notice again that you've got to use the appropriate notation, the line segment symbol on top. So the next thing that we talk about is arcs. Okay, so an arc is going to be any unbroken portion of your circle. It's any curved portion of the circle. All right, and it's going to have a measure that's between 0 and 360 degrees. Kind of think about the circumference of a circle or the degree measure of a circle, right? A circle we know is at 360 degrees from start to finish. Semicircle is going to be an arc that's half of the circle. So you know that half of a circle or half of 360 is 180 degrees. A semicircle has to be named with 3 letters, and the endpoints have to be those of the diameter. So if I take a look at this circle that's on the bottom, I know, and by the way, the arc symbol, which we did not just talk about, but the arc symbol is kind of like an arc, right? So I know that one of the semicircles, as long as the endpoints of the diameter are the endpoints of my circle, if I want, or the endpoints of the arc or the endpoints of my diameter, sorry. So if I want to talk about the bottom half of my circle, if I want to go in this direction, then I need to realize that my middle letter is that letter H in this case. So I know I'm talking about the bottom half of the circle. The endpoints have to be the endpoints of the diameter. If I want to talk about the semicircle that's on the top, if I want to talk about this semicircle, then my arc has to be arc A, CB. That middle letter tells you which direction around the circle you're going to go. A minor arc is an arc whose measure is less than 180 degrees, less than half of a circle. So if we take a look at this particular circle that we have right now, we could actually get the one that's on the bottom, right? So let's look at this bottom circle. If we want a minor arc, and it says name it with 2 letters, why not name a minor arc this guy right here? How about from here to here? So that would just be arc PN. If you call it arc NP, doesn't make a difference. If we talk about a major arc, that's an arc that is more than 180 degrees. It's more than half a circle. So let's say we want to start from P again, right? We could do that, and we could say, I'm going to go from P through N down to Q. That's more than 180. It's got to be named with 3 letters. It tells you that. So what I could do is I could call this particular arc, arc PNQ. Okay? So if you kind of wanted to use those same letters, right, but maybe you wanted to go in a different direction, how about something like this? We could have arc PQN be a totally different arc. So arc PQN is another major arc. All right, so the deal with arcs is if you're dealing with a semicircle, you need to use 3 letters. If you're dealing with a minor arc, you need to use 2 letters. If you're dealing with a major arc, you need to use 3 letters. Either way, you've got to have that symbol for arc. Now we start talking about a central angle. So the central angle is going to be an angle whose vertex is the center of the circle. So essentially here, this angle right here, angle PON, That's a central angle. Well, there's something about the central angle and the arc that it sits in. So if I were to kind of outline this central angle, hopefully you realize that it happens to be sitting in this particular arc, and this particular arc happens to be a minor arc. Well, there's something that you need to be able to see about central angles and their arcs. I'm going to actually pull up the sketch pad. Alrighty, so if I take a look right now, I've got this central angle, angle ABC, and it's right here, right? So angle ABC. It tells you that the angle is 126.54 degrees, and the arc it sits in is also the same measure, right? So the angle which is here, and the arc which is here. I can manipulate this circle, I can manipulate the angle, but notice how the central angle and the arc it's intercepted in remains the same. So again, we can kind of make the arcs bigger or smaller. It doesn't really make a difference. I can make my circle bigger or smaller. And all you need to understand is that the measure of the angle, the central angle, is equal to the measure of its arc. Okay? So I'm going to come out of that and go back here. So the measure of the central angle, PON, is congruent to or is equal to the measure of its arc. And that's what word gets filled in here, is equal. Okay? What you need to also understand is that the degree measure of an arc is not the same as the length of the arc. I'm going to show you that sketch pad also. So what you need to understand is that, for example, like arc EC, not EC, hold on. I think that's EF. So central angle, I'm going to go out here. Central angle, COF, is not the same as arc measure EF. And kind of think about it, right? If you're going to measure an angle, you're going to measure it in degrees. If you're going to measure the length of something, you're going to measure it in centimeters, inches, whatever it might be. So let me just show you a quick sketch pad here. So what you see is we've got this central angle, which is ABC, which is 126. The measure of the arc, AC, it sits in is 126. But the length of that arc is not measured in degrees. It's measured in centimeters. It's like taking a piece of a crust of a pie, or of a pizza pie or something, the crust, and it's got a curved portion to it, but if you straightened it out and took a ruler, you're going to measure it. Okay, so really the biggest thing is that arc measure and arc length. How come I can't manipulate this? I don't know. Maybe not. So arc measure, for some reason I can't move this. I don't know why. Sorry. So arc measure and arc length are not the same. All right. So you've got this arc measure, which is here, 126 degrees, and the arc length, which is 16. Oh, now all of a sudden everything moves. I don't know what happened. Not really worried about it. Is this it? No. Okay. So we're going to get to the next part of the lesson. We're going to go over here. So then you've got something called congruent circles. And congruent circles are circles that have the same radii or congruent radii. So we could all have, just different circles. And we could say as long as the radii are congruent, then we have to call the circles congruent. Arc addition, something that we have done with like angle addition and segment addition. So basically, if we wanted to take arc AB, come on, let's try this again. If we wanted to take arc AB, which is this guy, right? And then that's supposed to be curved, and then we wanted to take arc BP, that was supposed to be in a different color. I don't know why this is acting up. Arc BP, as long as they have one common endpoint, and that would be B in this case, right? So AB and BP, as long as they have one common endpoint, then we can basically add them together, and that becomes the bigger arc of AP. Okay, that's all you need to be able to do. So the final thing that we'll end up with is being able to do some of the math. So you have circle O, that means the center is O. You've got line segment AC, line segment BE. Those chords are diameters. The measure of angle DOC is 40, and the measure of arc AE is 80. We want to find all these other things. Well, arc ED. Arc ED is this guy right here. But what ends up happening is we know central angles are equal to their arcs. So that means arc CD would have to be 40. But then hopefully you realize that this whole big arc from A through D to C is a semicircle. 80 and 40 are 120. What's missing is 60 degrees. So that's what happens with that guy. Angle EOD is this central angle right here. Well, central angles are equal to their arcs. So the central angle is 60. Angle BOC. BOC is this guy right here. But again, realize that you've got this diameter, you've got 60 and 40, so arc BC happens to be 80. Central angles are congruent to their arcs, so angle BOC happens to be 80. Angle AOB. Well, here's a diameter again. We already have 80 degrees of it, so we know that the rest of the arc is 100, which means its central angle is congruent, so this becomes 100 degrees. Arc AB, did we find that one out yet? AB. So arc AB happens to be that angle that we just found out, the central angle, there's its arc. Arc BAD, 3 letters. So from B through A to D, I'm going to kind of, well, I can probably go around here. So where's B? So from B, right here, through A, ending at D, says we're adding 100 degrees plus 80 plus 60. 100 plus 80 plus 60 is 240. And then last but not least, from D through B through E, so from D through B through E, starting here, D, B, and all the way around. What's interesting is, this might be better to highlight it. Actually, let me erase this for a second. If we go from D through B to E, it's every part of the circle except this 60 degrees, which means just do some subtraction. 300 minus, or 360 minus 300 is 360 minus 60 is 300. All right, that's it. All right, so you should be good for homework.